Welcome to EDU World Space.
This question is asking about the energy of an electron when the lobes of a given d orbital point directly at the ligands, and whether or not that electron has higher or lower energy than an electron whose lobes do not point directly at the ligands. And this is discussing the interaction between the metal and the ligand. And so if you can imagine a metal ligand complex, like I've got shown here, where you have ligands coming in on the X, Y, and Z plane, and the electrons that are contributing from both the metal and the ligand. You can then think about the d orbitals that exist in this metal ligand complex, and there are 5 d orbitals that exist for this complex. They are dz squared, which has this configuration, dx squared minus y squared, dxy, dxz, and dyz. Now, the energy that an electron requires to interact between the metal and the ligand is determined by a couple of things, one of which is electron-electron repulsion. And so if you have an orbital like the dx squared y squared, where you have these orbitals directly going out into the x and y plane where they'd be interacting with the ligand, you're going to have an increase in electron-electron repulsion, as opposed to something like the dxz or dyz or dxy, where those orbitals exist in between 2 planes. So in the case for the dyz, these orbitals stick out between the z and the y axis, and so they wouldn't necessarily interfere as strongly with the electron that is on that ligand coming in on that y-axis or that z-axis. Therefore, to answer this question, the energy of a electron that is in the plane of the metal ligand is going to have higher energy.